The Vector 3D Workbench might have looked like it's been sitting idle for a little while now, as I've not really provided much in the way of updates. Sorry about that. But today that changes. So strap in, it's time to find out all the information you need to know if you want to get hold of your very own Vector 3D Workbench. Hello everyone, my name's Adam and welcome back to the channel. So today, of course, we're going to be doing the big update on the Vector 3D Workbench, the kind of current status, what's happening, what's changed, what I've been testing, and of course, how you can get your hands on one. So let's get stuck in with what I've been doing since the last update. So since you last heard from me, quite a few things have actually happened, even though it might have looked like not very much has happened. So mainly lots of testing and going through a lot of the suggestions that I gathered from the videos that I made. So thank you everyone who provided lots of really good feedback and suggestions on things that could change or things that could be better. So I have looked at pretty much all of them, I think, now, and in quite a bit of detail, enough to make sure that some of those ideas are feasible, possible, kind of cost effective and all that sort of stuff. But they won't actually be necessarily available at launch, so sorry about that, but it probably will come just a little bit further down the line. So speaking of the launch, I have actually been working out how that's going to work. We'll talk a little bit more about that in a minute. I have actually also been procrastinating quite a lot, as quite frankly, the entire process is rather terrifying. But we are moving forward now, so no more procrastinating. It's time to get this thing launched and we're going to succeed, and it's going to be brilliant. While doing all of that stuff, I have of course been implementing a bunch of changes, some big ones, some little ones, some from your suggestions and some from my own. So let's go through a bunch of those changes now that you'll probably want to know about if you're looking at getting one of these Vector 3D workbenches. So firstly, the workbench will be available in two sizes. There'll be the big size or normal size, I'm not sure how we're going to call it yet, but it's the 1200mm width size, and that'll be 700mm deep. And then the half width size, which you guessed it, is 600mm wide. It's also though 700mm deep and the same height. So all the dimensions will be basically the same for both, other than the width, which will be half the size on the smaller one. Personally, I think that's going to be a really good option for those that don't have necessarily like a dedicated room or a garage, but do want a dedicated space to do their 3D printing and other work relating to it. Next, there's no more anti-vibration built into the workbench. Now, I can understand that you may be upset about this, but honestly, really, you shouldn't be. I did test loads of possible configurations, methods for reducing the vibration, reducing noise from printers, but ultimately none of the solutions that were implemented into the workbench and were cost effective were worth doing. In every single case, it was much better to remove that vibration before it gets to the workbench rather than after. Hello everyone, it's Future Adam here while editing. I don't feel like I explained this part particularly well, so I just wanted to clarify. And to be honest, even now, I'm still not sure I can explain it quite how I want to explain it, but we'll give it another go. Essentially, the solutions that I'm looking to provide need to be something that I can ship around, and they also need to be sensible and cost effective, as well as being repeatable and all that sort of stuff. One of the materials that kept being suggested is concrete, and that I think is in part to the video that CNC Kitchen did with a large piece of foam and a thick concrete slab, and that is a great solution, but it's not part of a workbench. So if I want to integrate something into the workbench, it would have to be kind of a little bit different to that. So some people suggested creating the entire worktop out of concrete and all this kind of thing, but in reality it's just not a feasible solution to be creating those things and shipping them around. Ultimately, what I'm trying to say here is that the best solutions are still those ones, like from CNC Kitchen, that you can add on to specific printers in specific ways. It's better to do it before the vibration gets to the workbench, rather than trying to use the workbench to reduce the noise of the printer. The best methods that I came up with did reduce the noise by a very small amount, but this was often not as much as simpler solutions and always cost more. I think it's probably pretty obvious at that point why those solutions are not going to be something that I will bother selling. That's not to say you can't do them yourself. By all means, if you have a good method for sourcing all the right parts and making it yourself locally, then I thoroughly encourage that. If it's what works for you, then go ahead and do it. But it doesn't work for something that's got to be shipped around and be reliable and repeatable. I just want to provide you a great value quality product, and I don't think the anti-vibration would be that in its current iteration, so it's not going to be that. So hopefully that clears it up. It's a little bit disappointing because I thought it was a good idea, but at the end of the day, turns out from all the testing I've done, it's just not really a great idea. The better solution is to remove that vibration much closer to the source rather than letting it get to the workbench and then trying to do something about it. The next thing I should mention is that not all available modules or all modules that I've done some work on will be available at launch. The reason for this is I want to keep the launch fairly simple. I want to walk before I can run, if you see what I mean. I don't want to try and launch everything all in one go and then have little bits fall or fail here and there. I want to keep it simple to start with, provide you really good fundamentals, the great workbench frame and upper storage shelf and the lower storage area and all that great stuff, but just not with all the extra added complications right at this first stage. One module that I have added in that wasn't there before that you won't have seen is a shorter lower shelf. So the lower shelf originally was the full depth of the workbench, which is great if you want maximum storage space and if you stand at the workbench most of the time. For me, that's typically how I tend to use it. But a lot of people want to be able to sit at the workbench like I am now, and for that you need a little bit of leg room or foot room. So you want that shelf to be a little bit further back to give yourself plenty of room. So there will be a second lower shelf module which uses pretty much all the same pieces, which is blooming brilliant, but the work surface, the actual shelf piece is going to be maybe not quite half the width. It might be exactly half. That might be a really good way to do it, but it will be shorter to give yourself some leg room for those people that like to sit at their workbench rather than stand. The upper shelf, which is the kind of narrow shelf that sits right high up on the workbench, or well, by design does, but obviously you can put it anywhere you like. That shelf that we looked at early on, it did have like a fully surrounding frame, and then I was thinking maybe just the two arms that come out the side. So I've changed that design a little bit. The shelf is deeper now, so it can support your kind of Ender 3 style printers. The kind of smaller printers will fit up there really nicely, and so happy about that. The frame doesn't go all the way around the shelf, but what it does mean is that the parts for that shelf are now the same as for the filament enclosure, which could be really beneficial for that upgrade cycle and helps production because it's fewer different parts that need to be made because we're reusing the same parts to do two different designs, which is really, really good. I have also added end caps in a few places. So this is just a plastic cap that sits at the end of an extrusion. The reason for doing that obviously is that A, it covers the end and looks a little bit better, and B, it covers the sharp edge. So in a couple of places where that was an issue, I've rectified that with those end caps. The bottom of the workbench, so right at the base of the legs, that can be equipped with either leveling feet, and then the second option is to have wheels. With the wheels, you don't get the same level of vertical adjustability because you have to bolt them all the way in, but what you do get is the ability to move the workbench around, and that is amazing. Next, let's talk a little bit about the upper filament enclosure, so that's the bit just off the top of the screen up here. Originally, the panels so they're clear panels around the filament enclosure, were all PETG. So if you wanted to be drying filaments at maybe 100 degrees Celsius, you could have some problems with those panels. After doing some testing, we can change those panels out for polycarbonate, but there are obviously other components within that enclosure that also need to have that level of thermal resistance. The main problem here is the seal. So the actual seal itself can become quite soft, and in most places that's absolutely fine because the seal does not support the panel. It just seals against it on both sides. For example, the panels that are sitting vertically sit in the bottom of the slot and the seal clamps around the side. But where the panel is horizontal, the actual panel sits on the seal, and when it gets too soft, that can open a gap to the top part of the seal, which is not ideal. So there are obviously some ways we can look at solving this, potentially changing the seal material, etc. But at the moment, I'm looking at that filament enclosure in its current iteration to be mostly concentrated on either low temperature drying, sort of maybe up to 60 or 70 degrees, or the ability to just dry using desiccant or any other methods like that, like not temperature-based drying. I have also done some thermal testing on a couple of other components, as well as some flammability things to check for like materials extinguishing if they were to catch fire, for example. So that's all looking really good and seems all pretty safe so far. The doors, people commented, generally looking quite thick and heavy and very expensive. Now, the whole upper enclosure is quite an expensive assembly. The features and performance that it gives are quite high, so there is a fairly high price that goes along with that. I have looked at multiple other options, including smaller extrusions and less rigidity and all this kind of stuff, but ultimately I couldn't achieve the same performance with a lower cost. So like there were lower cost options, but it added complexity, which then increased cost elsewhere. So the overall cost just ended up higher and it just was worse. Or very similar, it's like it just wasn't worth it. So although the doors are quite thick and are quite heavy and are reasonably expensive, they do perform really, really well. And there don't seem to be many great solutions for doing it otherwise. However, that being said, I am also looking at providing some low-cost doors, but they won't have the same sealing performance as these ones do. The last big question about the printer was in the connectors. So the connectors in all of the joints, we did that video on all the different methods that I'd found, and there was an additional one which wasn't mentioned in that video, and that's the auto connector. So obviously that doesn't really tell you much. Obviously it doesn't just kind of all snap together when you get them close. It's not automatic. So anyway, despite the slightly weird naming, the auto connector is a connector that you can screw into the end of one piece and then have a screw that goes through that screw-in part into the other part. I'll put something on screen to help you understand what I'm trying to explain. But basically, they do have some advantages. They are a little bit lower cost and they don't have any processing required on the extrusion. For example, this quick connector, it needs that hole in the extrusion in order to function. The real problem for me with the auto connector was it's not symmetrical. It sits on one side of the extrusion, which gives you a really strong joint in one direction, but it's really quite weak in the other. You can solve this by having two auto connectors, but obviously that really rapidly eats into the cost advantage. It's also much slower to assemble, and it also takes up spaces in the extrusion slot, which are going to be needed for panels, etc. So again, it just wasn't really viable with that kind of solution. Just had to answer the door for the postie. Anyway, so ultimately, due to some of the limitations, especially in the occupation of that channel, I've decided not to use them in most places. They have been implemented on the doors, and I think that's a great way to use them because there's less modularity needed around those. But in the main frame, their limitations in strength and their slightly reduced benefit in cost once you need two everywhere, it's just not that great. So how do you get a Vector 3D workbench? So we're going to be launching via Kickstarter. It's really not feasible for me to try and launch a product in any other way. I need the funds up front in order to get low production costs, in order to get a decent price to you. If we didn't do that, the price would be much higher and it just wouldn't really help anyone. So realistically, a crowdfunding campaign was the only way this was going to happen. Hopefully you'll agree that I've done a lot of the legwork up front and there should be a fairly good chance of the campaign succeeding, and I would like to think I can deliver on that promise as well. As I've mentioned, not all the modules that I've kind of looked at for this are going to be available right at the start, but those will come after the campaign ends or the stretch goals during the campaign. So I'm very excited about doing more modules. It's just not feasible to do due to the complexity right now. Speaking of modules, actually, there are of course plans and aspirations for what we're going to do with those. So let's talk a little bit about where I think this workbench is going in the kind of longer term. So to be clear, there are already loads of ideas from both myself and from the viewers in the comments and feedback about modules they'd like to see and modules that could be possible, or kind of weird, wacky, bizarre things you could do with this structure. And in my mind, this is really an exciting part of this project, is its potential to really help a lot of people and be very adaptable to everyone's needs. I've done a little bit of analysis and kind of design, kind of implementation checking on a lot of the ideas that I've had and from the viewers, and a lot of them are looking really good as well. Some of them maybe a little bit crazy, but largely really great ideas, and definitely stuff that we can look at implementing a little bit further down the line, and I think that's going to be really exciting. So of course, there's a link in the description below to make your way to the Kickstarter so you can back the project. If that's something that you want to do, I'd be really thrilled if you do, because I'm really excited about the success of this workbench, and I think it has huge amounts of potential. Hopefully you do too. For now, thank you very much for watching, and I'll see you in the next one.